Welcome to Zen Live TV. This is the Alien Scientist Conspiracy and Science Controversy Hour. I'm your host, Jeremy, the Alien Scientist Riss, and today we're going to be talking about some interesting physics stuff. Again, the views on the show, expressed on the show from week to week, do not necessarily reflect the views of our sponsors, Zen Live TV, our producers, or any of the people the guests that we may have on week to week. So I'm also still looking for that sponsorship opportunity. I know I've mentioned this many other times before. If you're interested in sponsoring my show and getting ads out on this and helping support the free and open entertainment business that sponsors me and hosts my show and gives me the freedom to talk about the most cutting edge and controversial subjects in science, politics, and the solutions and stuff that they really don't want you to know about. Anyway, so today we're going to be talking about this new article that came out, and it just spawned a whole bunch of new thoughts back into a lot of stuff that I've sort of covered in past videos in the past. I haven't yet done a real in-depth physics sort of topic yet for my podcast, so I decided this week I'd do some in-depth physics talk and exploration, because this recent article just that appeared in Nature, it just really sparked my imagination, and I wanted to talk about it. So I'm going to do a little screen sharing thing through Skype. We're going to see if this works for my broadcast, so you can see. Maybe a little easier for you to see what I'm scrolling through on the screen there. But here we have this article, and I'm going to read you not the whole thing, but a couple things from this. And basically, the title of the article is "Superfluid Spacetime Points to a Unification of Physics," and thinking of space-time as a liquid might help reconcile quantum mechanics and relativity. That would be really, really, really cool. If there's been a lot of talk lately about how in the physics community, in the scientific community, about us finally cracking this puzzle of unifying quantum mechanics and relativity and forming a standard model or a complete picture of the universe. So there's a lot of some speculation that physics will essentially be over at that point. I think that I'd completely disagree with that analysis or synopsis, that some people think that somehow if we find this unification theory that it's going to give us complete insights of everything, and that physics will be over for some reason, that we won't need physics or the tools that physics teaches us to give us further insight into any other topics, which physics can be applied to so many things. I really doubt that physics would be over at that point, and there's still so much more left to explore using physics and using the tools of physics, that I don't think that statement or that synopsis that physics would be over if we were to find this theory is quite accurate. Anyways, thinking of space-time as a liquid may be a helpful analogy. It's although they pictured it space-time as this liquid, but they said that it would have to be a superfluid, and superfluid of infinite density, so to speak. So, which means that the higher density of a material, the faster waves will propagate through it. So if they have a super infinitely dense material, then they'll propagate at the fastest speed possible, which is the speed of light. So I thought that was this is interesting, because Tesla was the one to really stress that there was an ether, and used a lot of his insights into the foundations of electromagnetism and electromagnetic theory and wave physics, and a lot of that stuff was his models were based around the idea of an ether, not the ether in the sense of what's called a luminiferous ether. I think that's where some people get confused when you start talking about an ether. The idea of a luminiferous ether was debunked with the Michelson-Morley experiment, and reconciled with modern physics and the theory of general relativity. Einstein's theory of actually it's special relativity that reconciled that. But the Michelson-Morley experiment disproved the idea of a luminiferous ether. That's a light ether that they said that on one side of the sun, that they thought that relative to the direction that the waves of light were moving, they thought that during the morning time when you're rotating, the Earth's coming this way and rotating toward the sun, they thought that the speed of light would be faster. They'd be able to measure it faster than in the evening when you're going away from the sun and traveling with the waves. But that turned out to be false. The speed of light was constant no matter what speed the observer was traveling. So the speed of light is constant relative to all observers, no matter what their velocity is compared to or relative to other objects. So it's an interesting animal that they went and figured out. But that doesn't disprove the idea of an ether. Here I know on Wikipedia under ether theory it says that it lists these ether theories, the luminiferous ether and other ethers, and describe that this whole idea of an ether has been thoroughly debunked. Although it's not been quite debunked. There's more and more physics that's coming out like this that points to there being some type of that space-time, that this thing that we call the space between objects, space is much more properties than just emptiness. It's not just an empty thing. There's physics going on within this vacuum of space, which could explain and give insights into lots of the outstanding puzzles in physics currently. So I want to read a couple of things from this and sort of break it down, because a lot of this is really technical and a lot of people said they had problems understanding it. So I wanted to break down in particular a couple parts. So physicists have been considering the possibility since the 1990s in an attempt to reconcile the dominant theory of gravity on a large scale, general relativity, with the theory governing the very smallest bits of the universe, quantum mechanics. Both theories appear to work perfectly within their respective domains, but conflict with one another in situations that combine the large and the small, such as black holes, extremely large mass and extremely small volume. Many physicists have tried to solve the problems by quantizing gravity, dividing it into smaller bits, just as quantum mechanics breaks down many quantities such as particle energy levels into discrete packets. And there's also many attempts to quantize gravity using string theory and loop quantum gravity. As also alternative approaches and stuff. But so basically, quantizing gravity means breaking it up into little chunks and discrete chunks or discrete packets. And that's an interesting way of looking at gravity, especially the way that they're trying to reconcile this. An emergent space-time, one that acted like a fluid, would not be immediately distinguishable from a space-time of any other theory. So that's basically says that it would still have the properties. It wouldn't be a luminiferous ether. It would still have the properties that our space-time continuum does with respect to relativity and all these other things. But it would be it would act much differently. And this is giving some interesting insights into what I believe could be the key to this grand unified theory or this fundamental unity of physics that they're all talking about. I don't think it would be necessarily the end of physics, but it would be a huge, major breakthrough in our theory and the current standard model. So here we have these ether theories. Pretty much, it's not the ether as the luminiferous ether as they were saying, but there might be some other type of ether that exists there. And it's interesting that there's a couple articles. One was written by Eugene Malov in Infinite Energy magazine called "Tesla and the Ether." It's a couple pages long, and I won't read the whole thing because it's quite detailed and long, but I suggest going and reading this article. It's a great review of some of Tesla, his insights into this ether and technologies that could exist. And I suggest checking out this article. I'm going to link to it in the description below. But he basically talks about a lot of the same stuff: dark matter, dark energy, the whole ideas of what is this pervading ether or substance that's sort of hidden there, but has an effect on the universe and could explain the Big Bang and a lot of these other things. But this is interesting. This is from etherforce.com, which I haven't really got a chance to explore this website much, but they had a cool Tesla quote here that I've seen posted on Facebook and other places before, and I'll read that to you guys. Tesla said, "Only the existence of a field of force can account for the motions of the bodies as observed, and its assumption dispenses with space curvature. All literature on this subject is futile and destined to oblivion. So are all attempts to explain the workings of the universe without recognizing the existence of the ether and the indispensable function it plays in the phenomena. My second discovery was of a physical truth of the greatest importance. As I have searched the entire scientific records in more than a half-dozen languages for a long time without finding the least anticipation, I consider myself the original discoverer of this truth, which can be expressed by the statement, there is no energy in matter other than that received from the environment." So the idea is that it comes from that the idea is that energy can't be created or destroyed. It's one of the fundamental laws of this universe. So how did it all get here? That's the paradox with the Big Bang. Is if the universe came from nothing, then how did all this energy get here, and where did it come from? And another one of the interesting things of physics is relativity. Everything's always relative to other things. There's no independent observer. There's no ultimate observer. There's no ultimate standpoint or reference frame. All points in space are created equal, and all laws of physics are obeyed in everywhere at the same time equally. Then you have Newton's laws, specifically the one of conservation laws, which are some of the most important laws in physics, which is for every action there's an equal and opposite reaction, which means every time something happens, you apply a force to this, it applies the exact same force back on you. Anytime you apply a force on anything, it's applying the same exact force back on you. The forces are always balanced, equal and opposite. But yet things move around, but they only move around relative to one another. See, they both exert a force on one another, but because my mass is greater than this small rock, I'm going to be able to push that rock around, and the force that it exerts to my body is going to be negligent because my mass is so large relative to that what it's pushing me around and doing. Or when you jump off the ground, the force that you're exerting into the ground is so negligible that it's not going to really show up in the long run of things. But you're still, all the forces are balanced and they're equal and opposite. So there's this idea that no energy, as he says right here in this quote, there is no energy in matter other than that received from the environment. That's essentially saying that any energy that exists in matter is only existent or dependent on what's in the environment around it, and it's balancing out the entire rest of the universe around that point in order to exist. So this is I know that's a lot of words. I didn't really explain that clearly, but there's an insight here into what this fundamental ether is and how the universe is constructed, and all the laws of physics that we have, all the pieces of the puzzle that we're trying to fit together in this giant puzzle of physics right now are they all show us that there's these conservation laws, that everything's equal and opposite. And I thought that this was a very interesting idea, because it relates to a theory that I've been thinking about, but not really. I haven't really gone too far in mathematically expanding it or formulating it in a coherent picture of anything. But I think that I'd like to, and it's the idea of this 0 point being and the way of modeling a model for physics that could actually work to explain how the whole universe exists and where it all comes from and why all the laws of physics are the way that they are. But it's based around a 0 point, and that point could be anywhere in the universe taken at this point, and you have to write down what the laws of physics are for that point, and then it will apply to anywhere else. And sort of the idea that I had was that I started with the whole the paradox of the theory of nothing and everything, that in the beginning there was nothing, and that we somehow have a universe that was created from nothing, from nothingness. And I've sort of gone into a lot of physical discussions on the nature of nothing and nothingness. There's a lot of interesting books that I read in the process of this. One was Casey Cole, A Hole in the Universe, which was pretty good. It was a lot more philosophical than mathematical and whatnot in the approach, but it was nonetheless a good book that was quite insightful in a lot of ways. Here it is, A Hole in the Universe. And I thought basically how scientists peered on the edge of emptiness and found everything. And it's this idea of nothingness and how nothing couldn't be everything at the same time, but how you create a universe that has this such a complex, a holographic universe, because you can't really create a universe that's real or realistic, even though real is a relative term, I guess, when you're talking about theoretical physics, I guess. But I thought this was an interesting idea of nothingness. When you try to think of what a nothing is, and no thing, you have to address it as a thing. So even though you're calling it no thing, you're addressing it as something. So it can't really be nothing if it's something, because you're obviously identifying it and referring to it. So there's a lot of philosophical implications about this, and she talks about stuff like consciousness, of like nothing has to recognize itself or realize itself or become conscious of itself. In order for us to acknowledge that there was nothing, we have to say that was in fact something, that we call this nothing, or this entity, or this noun, or whatever word you want to use to describe it, that we describe as nothing. And what is nothing? And the more you think about what nothing is and try to ponder on the nature of nothingness, the more interesting and insightful some of the things that actually come out of nothing. And I've made jokes. I've left comments about this before, and people thought I was joking about. I've spent a lot of time thinking about nothing, and I wasn't like meant that I was thinking about nothing. It was that it's a philosophical term. And there's Heidegger writes about nothing as well, although I won't really go into his thing without my friend Matt here, who's the expert on Heidegger. But we've had some debates over this and before, but it's a different definition of nothing, what he talks about, the nothingness. If you look up nothing in the Stanford Plato Dictionary, I'll post a link to this stuff as well in the description. But I thought that this theory of it, I called it the zero theory, and I had it on an old website of mine. I took the stuff down because I really wanted to refine it and think about it and work on it a lot more. But it's this whole idea of a holographic fractal that's generated through a mirror sphere that's infinitely reflecting in on itself, which kind of like you have those halls of mirrors, and I have a picture of this screen right now of at least I thought I did. Oh yeah, here's one. The mirror cubes. Yeah, if you put two mirrors together, if you've ever been in one of those elevators before that have a mirror on each side, and the mirror over here reflects into that mirror, and basically gives the illusion that this elevator space in between these mirrors is reflecting off into infinity. And people have used this to make these mirrors. They put like a rope light in the middle of the frame, and then they take like a very thin strip of mirror and put it on the around the frame on the outside, so that it's slapped together, so that right on the edge of it's got a rope light, and then two mirrors that are face each other like this perfectly, and those reflect in on each other, so it creates this illusion of this these lights going in and extending into infinity, because the two mirrors reflect that space in between. The light just bounces back and forth and creates this illusion of this optical illusion of space, or an extended space-time continuum. So I was thinking that maybe that the universe could be generated from a fractal type reiterating function. Um, I'll get into what that means in a second, but that would basically be like a hollow mirror sphere or a three-dimensional sphere, or maybe even a four-dimensional hypercube or hypersphere that is just reflected in on itself out into infinity, and that at every point in space-time, it's another point of reflection, or because it's kind of interesting the way that space works between 2 points with light that travels between those 2 points, and the wave-like nature and how it propagates these waves through space, and how two particles can interact over great distances through photon exchange or particle exchange. But it's just an interesting insight that I had into this theory. But I'll talk about fractals now, seeing as I think that fractal mathematics and reiterating functions will be the key to creating a universe fractal, a type of equation that could be the final equation of the universe, or whatever you want to call it, the equation which generates the universe through a reiterating function. And the reiterating function in the case of our universe, I guess, would be time, because time is constantly plugged back into the function, and then something else happens, and then it spits out a result, and then each reiteration is basically like a quantum unit of time going by. However long a quantum unit of time is, it's probably 10 to the negative 28 seconds or something. I don't even know. It's maybe much smaller than that. Who knows? 10 to the negative 28 seconds, or picoseconds. I don't know. There's a lot of things on the quantum level that interact at those high of speeds, so it's hard to say if we were to make a quantized unit of time and then say that this equation could be the reiterating function which would generate a universe. But then again, the idea of this regenerating function is that it creates a mirror image of itself, but that extends into mirror images of itself, which extend into infinity in all directions. But each one of those is the exact same, has the exact same physics, or the exact same physics at a different point in the space-time continuum than the other thing. But then you get into the whole idea of how did things slip out of arrangement, that you suddenly have mass and all these laws that appear out of this mix, and how to get all the other laws of physics to fall out of this this reiterating function, or this bundle of equations. Maybe it won't fall out of the reiterating function itself, but maybe it can be analyzed through the iterations that are, or the basically the reflections that are made by this. Maybe that those can be analyzed, similar to you can't really understand what the Mandelbrot set looks like by studying just this simple reiterating equation. It's a quadratic recurrence equation, and you can't really get an appreciation or understanding for this fractal until you use computers to generate billionths of iterations and map them out billions of times, so that, and then use colors to map each sequential further iteration, so that as you iterate more, you get deeper and deeper and smaller and smaller into the detail. Because the first couple iterations, you maybe print out, the black outline and stuff, but you're not really getting into the deep details until you go really far out and do lots and lots of iterations. So it's not, essentially on what I'm saying is that maybe the universe is based on this type of an equation, and that we haven't come to it or been able to formulate it by trying to mesh these other bunch of equations together, because we basically, our model of physics has been studying the inner structure of these mathematically. We've basically been looking at this and studying this, and we're trying to find this equation that basically generates the entire function here. But we're trying to get to that by just looking at little discrete pieces of this and be like, well, it makes these circular things, and it does this, and then it breaks off and does this and does this, and we're trying to study this innate structure using, that's what our laws of physics, that's the equations that we're putting together. And we're trying to figure out what's generating it, which could be this, but we'll never get that backwards insight. You know what I mean? To get to the theory, I think that it needs to come from another way where we get this holographic fractal function, this reiterating function, which generates this holographic fractal. And then once we examine the fine structure and what that fractal generates and what it sort of creates, the curvatures of drop-off points with the reflections, like like if you have two mirrors that are slightly out of balance, it's going to eventually drop off this curvature, and you can never get them perfectly aligned. So where does that curvature end, based on the discrepancies, or even where does the resolution end after you go to a certain point where you can't see that far, or does it ever end? Or there's a lot of these questions that need to be looked at, but we're essentially studying all the laws of physics by looking at this fractal, or realizing that, oh, there's a lot of things in the universe that are fractal in it, or we realize that it's the structures that are called fractals, and that but we're not getting to, even though this Mandelbrot set, as I'm using as an abstract example, it still gives us some insight into how I think we should be looking at the laws of physics in order to fundamentally come to this greater understanding, or this greater single equation of the universe, or ultimate theory of everything. But anyways, we're going to take a break right now. It's at the half-hour break, and we'll come back and roll commercials.
Addicted to Ink, a proud sponsor of the Zaraza Entertainment Network, is Westchester's premier tattoo, piercing, and apparel destination, offering only the finest tattoo and piercing services, as well as the best atmosphere you will find. Addicted to Ink is located conveniently at 38 Westchester Avenue in White Plains, New York, right across the street from the Westchester Mall. If you got the itch for more ink, like the Zaraza boys do, get your work done right. Visit www.addictedtoinktattoos.com for more information.
Are you sick and tired of being sick and tired?
Yes.
Does the stress of daily life seem just like too much?
Yes.
Are you simply fed up?
Yes.
Do you wish you could just make it all chill out?
But how?
Well, then you need a Royale grinder. Royale grinder is a jumbo-sized 2.5-inch diameter premium 4-piece herb grinder that fits in the palm of your hand, with 50 closely interlined, everlasting chunky teeth that will keep on shredding whatever enters your chamber.
I can use it for all my herbs. Thanks, Royal Grinder. I'll never feel shitty again.
Order now at www.royalegrinders.com. That's www.royalegrinders.com.
Are you a smoker and you need to quit, but you're discouraged because it's harder than you like to admit? White Plains Vapors. Are you a non-smoker but you like to do the tricks? Well, these are non-toxic clouds that exit your lips. Oh yeah! White Plains Vapors, located at 210 Mamaroneck Avenue in White Plains, New York. Visit our location and choose from a wide selection of exotic flavors.
Back, Jeremy.
I'm gonna remember to unmute my mic this time. I forgot to unmute my mic last week, and
no problem.
I was talking for like 2 minutes before I realized it.
No problem.
But
no problem. Take it away.
And anyways, so I wanted to get back right before we took the break. We were essentially talking about this whole idea that I started off with the whole new theory that came out that they could model superfluid space-time by saying that space-time is a superfluid, that there's an ether, that it's a superfluid, and that it's not a luminiferous ether, but some sort of superfluid point, and that they could use this to unify physics, which is merge general relativity, Einstein, with quantum mechanics, the Schrödinger, Heisenberg formalization of physics. So the whole idea is that I got into some Tesla stuff. Talked about how Tesla was basically asserting that there was this ether, that it does play an essential part in how the universe is constructed. That there is more physics here that we're just now discovering, and I talked about some of these ideas that I had for generating a holographic fractal that could somehow create the space-time continuum using a reiterating function similar to what generates the Mandelbrot set. And then I was describing how we're trying to put these pieces of physics together by studying the innate structure of the universe, by looking at this map of it that we see around us. But this map might be being generated by another function which is just abstracted, and just because of the nature of geometry and all these other things, that it's generating the universe that we see. But we're trying to find that equation through studying the manifestations of how that's reiterating or generating or expressing itself mathematically through the three-dimensional universe in which we live in. So that's sort of the insights that I was giving into where I'm at currently with this quest for a quantum theory of everything, and trying to, find this innate secrets to physics that are on the cutting edge of everything. And I started out on a lot of fringe stuff and went through a lot of bullshit and a lot of fringe topics over the years, and eventually, staying in school and going through a real physics degree to learn the technical and the math and everything, so that I could get to the point where I actually understood a lot of the more complex physics, and has led me to a lot better information, and helped me to avoid a lot of other worse information and stuff that I've talked about in previous videos and stuff like. But anyways, I will get into some of that stuff. I wanted to talk about some of my previous videos. I thought that this was an interesting thing that they found. I often thought of space-time like a chessboard, and that I thought that this was an interesting article talking about how they looked at these graphene and crystals, and found that it divided the space up like chessboards. But they're still saying that they need to look at other types of things to see if other structures, to see if this thing is just a innate, odd, unique property of graphene's honeycomb structure, if this was generating the spins, or if it was something else. But I thought that was an interesting article that kind of pointed to this idea that there were some discussions going on with a couple of people that I've been talking to about the idea of space-time as this sort of chessboard that sort of creates this idea of black and white squares, though kind of it's the whole idea, not really a chessboard, more like a triangle or a Chinese checkerboard or something. But I thought that was interesting. The how that would fit into this model that I had of the what's spin, it's one side or the other. So maybe at every point, every point in existence is just a point on the surface of this four-dimensional hypersphere, or as you'd say, the colliding point of two separate three-dimensional spheres, which interact at a single point, and that it can either exist on one side or the other. Then you could have some sort of the form of the uncertainty principle fall out of that, where it could be in this sphere or that sphere, but one at the same time, and that the width of those is h bar over 2, the Heisenberg number, and then have the idea that this point of interaction be point in structure in space-time, and then on one side or the other it could be spin up or spin down, and then maybe this is a real spin is a difficult concept for people who aren't familiar with quantum theory to understand, because they think of spin as something physically spinning, but this is it's a property which is it's either one or the other, so they call it spin. I don't know that it's necessarily anything particularly spinning or actually spinning. They said it's electrons are thought to spin. They could possibly rotate, but recent work on graphene shows that an electron spin might arise because space at even small differences, not smooth, but rather segmented like a chessboard. The standard cartoon of an electron shows a spinning sphere with a positive or negative angular momentum as illustrated in blue and gold above. However, such cartoons are fundamentally misleading. Compelling experimental evidence indicates that electrons are ideal point particles with no finite. So anyways, it's basically these the idea of spin is this angular momentum vector up or down. Physically, spinning is inherently wrong. There's something else going on there that could be described by that. And again, I think it might be this division on which side of that sphere you're on, that reflection, which side of the reflection you happen to be on, and how it's balancing things out at that point to basically merge with the rest of the universe and mold along with it. But anyways, that's some interesting stuff. I think it might just be a property of the graphene. Graphene's a weird material, and I'm pretty sure that's just a property of the graphene itself, that they're going to find something there that will explain it. I don't really necessarily agree that space-time is segmented like a chessboard like that, or I do think that it's broken up into these discrete quantized packets of space, like that if you were to divide space, you do get to this finite point. It doesn't just divide infinitely and infinitely into itself. There is a fundamental limit where you get to this zero sphere, or this idea of a sphere of no, it's not really a sphere, but it's this point of the dimension of zero, this zero dimension, basically, where everything around it is just, it exists, but everything that's inside this is actually essentially nothing, or if it's a massive particle, then it's constantly trying to balance out with the forces of the entire universe around it, which is I don't know, it's an interesting way to think about the universal models of physics. And I want to talk about some of the other theories of everything and videos that I've done in the past, and talked about different theories that I've come across and then thrown away. The Garrett Lisi stuff was a really good video, I thought. People who saw the E8 theory and that whole idea, I think that's insightful. I think that there's definitely something worth looking into there with those Lie manifolds and the whole idea of E8 geometry and Garrett Lisi's thoughts on this quantum universe structure. But I also think it needs to be sort of combined with a lot of these other points, including I haven't thrown away completely Frank Sinardzic's work. I do regret now, when I did make that cold fusion video early on, where I was basically like calling out Obama on it was actually that video that let me bring it up so that I can show people the video I'm talking about. But I'll post a link to it in the description below. I'll find it later. But it was a video where I made it after Randy Powell's TEDx conference, where he started off with this Obama talk about energy. We don't have the technology yet to free ourselves from oil dependency on oil, and if you have it, let me know, and we'll get working on it immediately. And so that was what he started with, and then he's like, well, I have it, and it's Marco Rodin's flux thruster atom pulsar, and then he proceeded to spew a 15-minute long ramble of incoherent, mathematically sounding, non-technical bullcrap. And I won't even get into starting to address all the wrong statements or just incorrect and just nonsense that he mentioned there. But I've tested the rodent coil, I've built them, and they do not produce free energy. And so I was like laughing at that, and I was like, so I made a parody video, and using that same clip of Obama, and then basically saying that we had the answer, and I pointed to cold fusion, but I used Frank Zanardzik as the sole representation of what cold fusion was, and that was just wrong. You should never do that. That's like when the media, the recent attack on cold fusion that happened in the media, focused solely on Rossi and a lot of his shadiness and weird claims surrounding him. You know, a lot of people think he's legit. Some people think he's a fraud. Some people think he's just a opportune businessman. You know, I don't really know the situation with Rossi, as well as some of the other people involved in cold fusion. But after going to the MIT lectures, where I sat in a class for a week straight and took like a one-on-one course on cold fusion, where they basically, and I filmed those and posted them up online 2 years in a row. And then I went to the colloquium last March, and I got to meet like all these like top people in the field of cold fusion, like all the big serious people. I got to meet all the guys from Spay War, all the people from the U.S. Navy research, all the people from all these universities, like all the most accredited universities, like MIT. Those guys I already knew, Dr. Hagelstein and Schwartz, because I took the IAP course with them in January. But I also got to meet all these other like really key people in the field of cold fusion. So when I first had made that video, I was sort of touting Frank Zanardzik as the ultimate, you know, guy to go-to guy. But he may have a really great theory and a really great idea as far as his insight into this this property, which is completely coherent with the idea of a space-time fluid, superfluid space-time, where the velocity in that of light in that fluid changes for the velocity of light inside the atomic structure of the atom to get that quantum mechanical merge there, which will explain the spectral emissions and a couple other things. And I think it needs some work, though. It needs some fine-tuning and an explanation of how the fields collapse, where they go, and physically what they do during this interaction of photon absorption and emission. There has to be more physics there. They can't just be this black box model that quantum mechanics has currently, where it's just the electron just drops down the orbital and out spits a photon. There's got to be some physics going on there with the wave mechanics of how this thing drops and where that photon comes from, how that photon merges into existence, and what physics are involved there. And I think that Frank Zanardzik's theory is excellent for explaining that, but it was a poor choice on my part at that time, before I had more exposure to a lot more information on cold fusion, a lot more people in the field. Frank Zanardzik was actually the one who introduced me to cold fusion, because I wasn't really even interested in cold fusion until I learned about it through Frank. And then I was like, you know, hey, I started learning about it online, and then come to find out, they're like, yo, they're teaching a course on it right in my home state, you know, right downtown Boston at Cambridge, MIT, which I can get to no problem. And they're teaching like the best course that you can go to learn this stuff on it. And so I went to MIT and got to learn cold fusion right at MIT for free, and go to film it as well, and get the word out to a lot of people, and meet a lot of really interesting contacts and a lot of really cool people from a lot of different cool places. So I definitely think that I've learned a lot more about cold fusion in the time since I made that original video, and I was wrong to like just rest all the whole burden of cold fusion on Frank Zanardzik, and whether, you know, if his theory is incorrect, then suddenly it means cold fusion is incorrect too. No, I think that there's much more valuable insights that need to be looked at, and the fact that physicists are so like hard-headed and just completely ignoring all these recent discoveries that have come out in the field of cold fusion, with these real legitimate scientists and researchers are finding. I think that the more they continue to ignore those things, the more they're going to ignore really key insights that would allow them to really, you know, piece all this stuff together if they were more open-minded to it. But you get people like people out there that have a lot of the same exact old hat claims about cold fusion, about why it won't work, and some of these things are just not true. They've been disproven by numerous people, and one of the ones I hear repeatedly is that the radiation from, if the fusion reactions were actually occurring with these deuterium atoms fusing together to create helium, that the high energy gammas that would be emitted would kill people in the room. So the fact that these cold fusion scientists are alive and the machine didn't kill them is proof that they weren't creating fusion in their laboratory. But that's ignoring some of the physics that are actually going on here, which generate the fusion, because it's not fusion through the conventional overcoming of the Coulomb barrier, where they heat these things up and then just push them close together, and then they fuse instantly. There's some interesting wave mechanics going on in the phonon exchange in these lattice vibrations that they've discovered, where they get these collimated lattice emissions. So they get a bunch of these atoms that are all vibrating together in a pattern coherently, and when two of them fuse, they don't just spit out this one huge gamma like as normally they would. What Hagelstein and others that I learned about at MIT are suggesting is that there's a fractionation of the energy, that it fractionates or divides up all that energy and splits it out over all these atoms, which are vibrating coherently in this sort of superwave structures, and they actually get these collimated microwave emissions. So it breaks up that one gamma into a whole bunch of lower energy microwaves that get emitted in a coherent emission. And some of them get emitted, some of them can actually, they can control them to go into the wave itself to keep the wave going and generate further reactions. And putting them in a magnetic field seems to do that. I mean, there's a lot of really intricate and interesting physics that you could get into. I really suggest going to Cold Fusion Now and their YouTube channel and watching all those presentations from the colloquium that I filmed, and you get to hear it right from all these scientists themselves, and then read their papers and look at their stuff and correspond with them. Don't just write these people off and be like, oh, these guys are another Rossi or another Stanley Meyer or whoever else you might say or compare them to. This is an interesting field, and I think that the stuff that I learned about in that IAP course is I'm surprised it's still being ignored by the mainstream scientific community, and just because it's associated with the field of cold fusion, there's real physics going on there, and there's real insights being made into these really intricate quantum mechanical phenomena that are occurring at these levels, and I think that I don't know. There's a lot of interesting stuff that we could learn from studying things like cold fusion and not taking a blind eye to that. Anyways, I don't want to get stuck in too much on cold fusion. I kind of wanted to stay on this whole idea of this superfluid space-time unification and talk a little bit more about Frank Sinardzik and his theory. I need to get Frank back on. I talked to him recently. He's going to he wants to come back on and talk. I actually also talked to the guy over at Seattle for 9/11 Truth, who created all the 15-part series on Frank Sinardzik and messed up his math in a couple places and made a couple mistakes here and there. And I mean, he did a decent job, and those were fun videos and really cool for people. But I don't know. He's a good guy, and I want to get him on too, and so we could do an update with him, and he could tell you all what he's been up to, and we could just get into some of this physics stuff for a little bit. But in any case, I'll do that at some point. I'll have to get Frank Sinardzik back on because he's an interesting guy to talk to. He's got a very interesting theory that done a lot of really in-depth and more technical videos on it. Some of them were just to show the math and hopefully have people like pause and go back and really work it out. But I was working on those Excel spreadsheets. That was the last thing I was doing with Frank Sinardzik's work and trying to predict get hydrogen right. If I can get the orbitals and the spectral emissions for hydrogen right using Frank's theory, then I assumed that it was like a good theory and I was going to go on from there. But I was running into problems with that. I never could get it working, and there needs to be some adjustments added to Frank's theory in order to make it actually work and get results that would be interesting. Because I showed it and talked about it to my physics professors, and I started learning about that and making it when I started taking quantum mechanics. So he told me to put that stuff away and really just take quantum mechanics and learn it this way first, and then we can talk about this after. So I did. I put that aside, and I took quantum mechanics in college, and actually learned the Schrodinger equation, the Schrodinger formalism, and Hilbert spaces, and how to do vector products and function space, and dot products and function space is essentially the Brockett notation, and all the conventional quantum theory from we use Griffiths as our introduction to quantum mechanics as our textbook, and we did go into a bunch of other history of quantum mechanics and other kinds of stuff, and then work modern quantum mechanics and notations and formalisms and stuff, Feynman diagrams, and and path integrals and all that kind of stuff. So we got into a good overview of the way physics is really done, which was definitely helpful in me coming to a better understanding. But I never went back to that Excel spreadsheet that I had done before and worked on it again. And I don't know, I might do that when I have more time, but it's one of those things where I consider it a lot of work, and you need a lot of free time to do that kind of stuff. And right now I kind of want to make a lot of videos. I have a lot of scripts that I have written and videos that I have planned that I want to start cranking out and do work on. And then I got the Venus project. They want me to start doing a technology review thing for them, because I want to start branching out with a lot of these technologies and helping those people in that group, because they seem really dedicated to very similar goals to what I talk about here. The emergence of our humanity to a space age, spacefaring Type 1 civilization, renewable, sustainable, and completely like a futuristic society that's actually economic and can live and won't destroy itself and continue to pollute the world unnecessarily and endlessly, so I don't know. I'm not necessarily. I've got a lot of things that some people in the conspiracy. I've attracted a lot of people in the conspiracy movement over to my stuff, but I say a lot of things that some of these people disagree with, and I agree with a lot of things that they are maybe disagree with. One, I downplay the chaotic, just because of the chaotic nature of weather. I downplay a lot of the effects of HARP and I understand that there's papers written on HARP being used as a weather modification technology. I understand that there's some truth to heating the ionosphere and changing weather patterns or affecting cloud formation and other things through this ionosphere heating. I understand that those things are possible, but just and even with chemtrails, it's not chemtrails, but even using contrails, as they are, even using contrails to make clouds, to seed clouds, you lay down contrails in the cloud trail. You ever seen? Sometimes a plane flies and leaves a contrail, and then it starts to spread out and form a big cloud. Well, if you do it right and you put them in the right places, you can get them to form huge clouds, and then it's cloud seeding. You can basically get them to form bigger clouds by seeding the clouds and stuff. So there is some truth to that. You can do that, but nature is a very strange and chaotic environment, and anytime you tamper with it, it can never be exact. You can only do things so much. There's not we don't have the technology to completely control the weather accurately and articulately, and I think that that's actually a good thing. I'm not against that in any way. I don't think that it's a bad thing to be able to control the weather, as long as you're not creating floods or fucking things up and killing people or using it as a weapon. If you are doing it just in the general name of science and trying to understand climatology, weather patterns, and how to gain control of the weather, then that's not a bad thing, and I'm not against that. And in fact, I think it's a good idea. It's part of the Kardashev scale to become a Type 1 civilization, to have complete control of your Earth's weather and natural environment. So that means like control of the sunshine. So if there's a massive solar flares or solar activity, you're protected from that with like some sort of array or lens or solar array between the Earth and the sun. that would need to be built for Type 1, and also better ways to control the weather on Earth itself with other techniques. Maybe not like completely accurate, but at least to be able to break up giant hurricanes or typhoons so that they can't cause massive damage, or the other things. There's other methods, and use them for good, not as to create typhoons to go and destroy villages, but use them to like break up typhoons and prevent them from destroying, villages and countries and cities and stuff like that. So I think that, the weather modification thing, I think it's blown out of proportion by a lot of people. I'm glad Jesse Ventura recently did a thing on the chemtrails conspiracy, and he talked to a lot of good scientists, and I thought that was great. I'd really like to see him talk to more scientists, but not ones like Judy Wood. Anyways, I thought that was interesting, that because I never fell for the chemtrail stuff. I did my own experiments back when I first started hearing about them, and I started taking some data and looking into the science of contrail formation, and realized that they were just contrails, and that the whole idea of them spraying everybody with toxic chemicals is kind of stupid, because then they'd be also spraying themselves and their families, and it would just be not the easiest way to get rid of people or poison them, or do whatever they wanted to do for some diabolical population control agenda or whatever you want to talk about. But in any case, those are topics obviously for another day. We got 3 minutes left and we're running out of time. So anyways, I wanted to do, I thought that this Nature article on the superfluid spacetime points to unification of physics. That article, definitely go and read that. Check out the paper. Check out some of the other stories on it. I thought it was definitely an interesting idea. It's definitely jives with a lot of the other stuff I've been talking about, a lot of the insights that I've been sort of seeing into this unification of physics. But again, it's I don't think this is going to be the ultimate unification of physics. I think it's just another piece which is leading us to understand that what we're going to find, that the universe is some sort of fractal-like holographic function, which generates a holographic fractal. And that holographic fractal is the universe, and that if we want to find the ultimate equation of the universe, we need to find out that generating function, and that may not, and all the equations of physics that we have may not be the perfect insights into what that generating ultimate equation of the universe, that generating function is. But I definitely think that the hollow mirror sphere and the idea of that reflection, those mirrors that reflect in on themselves to create the illusion of dimensions and the illusion of space, I think that that's an interesting idea, to say the least. Anyways, I'll leave it at that, and we'll thank you for our sponsors once again. If you want to get on a sponsorship with this show, contact me through email, and or contact Zen Live TV. And thanks again for watching.